lovely students. Today's video is also a continuation of our previous two videos where we studied graphs. So today we will be studying a new topic in graphs, that is isomorphism. Now what is isomorphism? Isomorphism says that two graphs, if they are equal, they are said to be isomorphic. Now when I say equal, that does not mean geometrically equal. As I already told you that in a graph the geometry does not matter, or in other words the size and shape of the edges or lines does not matter. So when I say two equal graphs, that does not mean geometrically equal, but that means two graphs that are equal in terms of their properties, right? So what is isomorphism? How am I going to identify if I am provided with two graphs? So how am I going to identify whether those two graphs are isomorphic or not? So there are certain things that you need to keep in mind while checking for isomorphism. The first point is that it should have the same number of edges. Now if I am provided with two graphs, let us say this graph I call H and the other let us say the first graph I call G and the other graph or the second graph I call H, right? Now if I want to find out whether these two graphs are isomorphic or not, so what are the properties that I will be checking? First of all, I will check whether both these graphs have the same number of edges or not. Then I will see if they have the same number of vertices or not. Then I will check the degree sequence. That is, both the graphs should have equal number of vertices with the same degree. Then it should have one-to-one and onto function mapping. So these are the four properties which are must for any two graphs to be isomorphic. If any one of the properties is also not present or is not matching between the two graphs, then those graphs cannot be isomorphic, right? So let's see the first graph first of all. So these are my two graphs, right? Graph G and graph H. Now if I push this line, see, I have to prove whether these two graphs are isomorphic or not. So I am provided with a simpler graph G and H. I will see if I can push this particular edge, the edge that is common to vertex V1 or V2. If I push this particular edge upwards, please look carefully. If this particular edge is pushed upwards and the edge between vertex V4 and V3 is pushed downwards, so will I not get the same graph as the graph G? See, this is my vertex V1. I am talking about the graph H right now. My vertex V3, vertex V4 and vertex V2, right? Now these two vertices are simple and same like that of graph G. Now in these two crossing, if I see these crossing edges, if I push the edge of vertex V1 and V2 upwards, it will be like this, right? And if I push this particular edge of vertex V3 and V4 downwards, it will be like this. So just by adjusting the graph or flipping and rotating the graph, I can get a simpler version. So now you can see that this graph, after pushing these two edges upwards and downwards, looks like this, right? So is it now not similar to the graph G? So I have got a simpler version of the graph H, which is almost quite similar to the graph G. Now clearly I can see what are the number of edges. If I talk of graph G, what are the number of edges in graph G? 1, 2, 3 and 4. So that means total number of edges in graph G is 4. So then the number of edges in graph H. How many edges are in graph H? 1, 2, 3, 4. Now I will erase this graph because I have pushed the edges upwards and downward and got a simplified version of this graph. So how many edges are there? 1, 2, 3 and 4. So again, graph H also has 4 edges. So this is my graph H, which I got after pushing one edge upward and one edge downward of the original graph. Now I can see that number of edges in graph H are also 4. So the first property I have checked and they are equal. Now let's see how many vertices are there in graph G. 1, 2, 3, 4. In total there are 4 vertices in graph G, right? And how many vertices are there in graph H? 1, 2, 3, 4. Again, the same number of vertices, 4. So this property is also matching. Now I will see the degree sequence of graph G. How many, what is the degree of U1? The degree of U1 is 2 because it has 2 edges incident on it. Then again the degree of U2 is 2 because it has 2 edges incident on it. Degree of U4 is also 2 as again it has 2 edges incident on it. And degree of U3 is also 2 since it also has 2 edges incident on it like this. So that means the degree sequence is like 2, 2, 2 and 2, right? Then if I check for graph H, the degree of V1 is 2 since it has 2 edges incident on it. Degree of V4 is again 2, it has also 2 edges incident on it. Then the degree of V2 is 2 again, it also has 2 edges incident on it. And the degree of V3 is also 2 since it also has 2 edges incident on it. So again the degree sequence also is same here. So we have the same number of edges in both the graphs, we have the same number of vertices in both the graphs, and the degree sequence also is same for both the graphs. Now the next most important task or the fourth task is to see the mapping. That means there should be one-to-one and onto function mapping between these two graphs. Now if I look at this particular vertex U1 of graph G, it can be mapped to which vertex? It can be mapped to vertex V1, right? If I look at the vertex U2 of graph G, it can be mapped to vertex V4. We are looking for corresponding vertices. Only corresponding vertices can be mapped. So U1, as you can clearly see from the graph itself, U1 can be mapped onto V1, U2 can be mapped onto V4. Then U3 can be mapped onto V3 and U4 can be mapped onto V2, right? So this is the mapping that we have done. Now we will validate this mapping, right? Now here an edge between U1 and U2 exists in graph G and H. So in graph G an edge between U1 and U2 exists. You can see. So that means if U1 and U2 correspond to V1 and V4, an edge between V1 and V4 must also exist. Yes. An edge between V1 and V4 is existing. Then, then if an edge between U1 and U3 exists and U1 and U3 correspond to V1 and V3, you can see that an edge between U1 and U3 is existing in G. So that means the vertices which are corresponding to U1 and U3 are V1 and V3. That means an edge between V1 and V3 must also exist in H. So I can see that an edge between V1 and V3 is existing in H. Okay. Now there is an edge between U3 and U4. So I can see that there is an edge between U3 and U4 in graph G. So that means for the corresponding vertices, that means V3 and V2 also an edge must exist between V3 and V2. So yes, there is an edge between V3 and V2, right? Now the last edge I can see that there is an edge between U2 and U4 here. And U2 and U4 correspond to V4 and V2. That means there must be an edge between V4 and V2, which is existing. So since U2 and U4 have an edge, so V4 and V2 also have an edge. So that means my mapping has been validated since there is an edge between the corresponding pair of vertices. Now I can say that these two graphs are isomorphic. Okay, now I will consider these two graphs, graph G and graph H. Again, I have to find out the same thing if these graphs are isomorphic or not. So, first of all, what I will do, I will check for the initial properties. The number of edges in graph G. What are the total number of edges? 1, 2, 3, 4, 5, 6. So, the total number of edges in graph G are 6. Then again for graph H, what are the total number of edges? 1, 2, 3, 4, 5 and 6. So the total number of edges in graph H are also 6. So in terms of number of edges, they are same. Then let's look at the number of vertices. Now the number of vertices that the graph G has 1, 2, 3, 4 and 5. So total number of vertices here are 5. Now let's look at the number of vertices in graph H. How many vertices are there? 1, 2, 3, 4, 5. The total number of vertices in the graph H are also 5. So now let's look at the degree sequence. Okay, so the degree sequence is somewhat like this. A is having degree 3, then B is having degree 2, then C is having degree 3, D is having degree 3 and E is having degree 1. So if I write the degree sequence in ascending order, in descending order it will be like 3, 3, 3, 3, 3, 3, then 2 and 1. So total vertices are 5, 1, 2, 3, 4, 5. So this is the degree sequence that I have for my 5 vertices. Again, let's check the degree sequence of graph H. So how many, what is the degree sequence of V1? 1, 2 and 3. So the degree sequence here is, it starts from 3. Okay. Then 1, 2. So the degree sequence here is 2. Then 1 for V5, 1, 2, 3. Degree sequence is 3. Then for V5, this is 1. Then for V4, 1, 2, 3. So 5 vertices, 5 different degree sequences, 3, 3, 3, 2, 1. So you can clearly see that the degree sequence is also same for both the graphs. So it has the same, both of them have the same number of edges, both of them have the same number of vertices, and both of them have the same degree sequence. Now it's our turn to find out the function mapping between these two graphs. Now function mapping becomes easier if we can simplify the graph. So that means right now these two graphs are looking completely different. So the function mapping is little difficult. We cannot imagine which vertex can be mapped onto which vertex. So let's just simplify this. How can we simplify this? Okay, now this is the graph H that we are provided with. Please look at it carefully. This is the graph H that we are provided with. Now, in order to find out the mapping between graph G and graph H, I need to simplify this particular graph H. Now, if I flip it or if I turn it up like this is the graph that I get. And then if I again flip it, this is the graph that I will get. Look at this graph. This is what I will get after turning and flipping the original graph H, right? And then carefully you can see. Now, as I said, the shape and size of the edges does not matter. So if you can see these three vertices, vertex, if you flip it like this and you look at vertex V2, vertex V1 and V4. If I look at carefully, vertex V2, V1 and V2 and V3 and V4. So if I push them upwards, if I push this particular portion upwards and straighten it, it will look exactly like this. This is how it will look if I flip it and straighten the edges. Which edges am I talking of straightening? I will straighten the edge, vertex V2, V1 and V4. If I push them upwards and straighten it, it will look exactly like this. So is this not similar to the graph G? Yes, it is very similar to the graph G. So all that you need is a little practice and imaginative skills. Of course, we all have imaginative skills. We just need to know how to flip and rotate a particular graph in order to get the original graph to which it is being compared, right? Okay, so now we get what we have, that is this particular graph. After flipping, what we get? We get a graph like this. So this is the final graph H that I got after flipping and rotating. Now I can easily find out the function mapping between the two vertices of these two graphs. So if I look at the function mapping, the vertex A can be mapped onto which particular vertex? The vertex A can be mapped onto V3. Vertex B again can be mapped onto V2. Vertex C can be mapped onto vertex V1. Vertex D can be mapped onto vertex V4. And vertex E can be mapped onto vertex V5. Right? Now let's validate this mapping. Now there is an edge between the vertex A and B. You know there is an edge between vertex A and B. So that means there should also be an edge between the corresponding vertices. That means V3 and V2. So yes, there is an edge between vertex V3 and V2. Right? Then, okay, there is an edge between vertex A and B. I can clearly see. So that means there must also be an edge between V3 and V4. So, yes, there is an edge between vertex V3 and V4. Then, there is an edge between vertex B and C. So, that means there must be an edge between vertex V2 and vertex V1. So, yes, there is an edge between vertex V2 and V1. Then, there is an edge between vertex C and A. So that means there must be an edge between vertex V1 and vertex V3. So yes, there is an edge between vertex V1 and V3. Now there is an edge between vertex D and A. If there is an edge between A and D, it is quite obvious there will be an edge between D and A also, so we won't check that. Now we can see that there is an edge between D and E. Right? So that means there must also be an edge between V4 and V5. Yes, there is an edge between V4 and V5. So we have validated our mapping. Alright, so we find that these two graphs are also isomorphic. Now we will consider these two graphs, graph G and graph H. Again we will see for the same properties. First of all, the number of edges in graph G are 1, 2, 3, 4. Then the number of edges in graph H are 1, 2, 3, 4. Same number of edges. Then we will see for the number of vertices in graph G, which are 1, 2, 3, 4. And then the number of vertices in graph H, which are 1, 2, 3, 4 and 5. So the number of vertices in both the graphs are not matching. So that means we will not proceed further because these two graphs cannot be isomorphic. Now we will look at these two graphs and find out if they are isomorphic or not. Again, we will see for the same properties. First of all, the number of edges in graph G. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are total 12 edges in the graph G. Then the number of edges in graph H. How many edges are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Again, there are 12 edges in graph H also. You can count it for yourself. Then we will see the number of vertices in graph G. So how many vertices are there in graph G? 1, 2, 3, 4, 5, 6, 7 and 8. Total we have 8 vertices in graph G. How many vertices are there in graph H? Total we have 1, 2, 3, 4, 5, 6, 7 and 8 vertices in graph H also. Now let's look at the degree sequence of both the graphs. Okay, if I look at the degree sequence of vertex 1, it is 1, 2, 3. So 3. Then for vertex 2, 1, 2, 3. Then for vertex 3, 1, 2, 3. For vertex 4, 1, 2, 3. For vertex 5, 1, 2 and 3 again. For vertex 6, 1, 2 and 3 again. For vertex 7, 1, 2 and 3 again. And for vertex 8, 1, 2 and 3. So this is the vertex sequence of graph G. There are total 8 vertices, 1, 2, 3, 4, 5, 6, 7, 8. And the degree sequence is like this, 3 for all the vertices. Then again, let's see the degree sequence for the graph H. So for vertex A, the degree sequence is B. 3 you can clearly see. For vertex B also it's 3. For vertex C, D, E, F, G, H. Again, total 8 vertices in graph H. 1, 2, 3, 4, 5, 6, 7, 8. Right? 8 vertices and the degree sequence is 3, 3, 3 for all the vertices. So that means the degree sequence of both the graphs is also same. So we have the same number of edges in both the graphs. We have the same number of vertices in both the graphs. And we have the same degree sequence for both the graphs. So that means we can proceed further. Now what is the next step? To find out the function mapping between these two graphs, that is the graph G and graph H. But how do I find which vertex will be mapped onto which particular vertex of both the graphs? As I told you, we need to simplify the diagram or graph for that. So how am I going to simplify the graph? Now look at this. This is the graph G and this is the graph H. Now graph G is quite simple in itself. What will I try to do? I will try to simplify the graph H. Now if I look at graph H, it is looking like this. The graph H looks like this right now. You can see for yourself, it looks like this. Now if I flip it like this, can you see? If I flip it like this, then you have a graph where AB is on top and where AB and CD and then EF and GH. I get a cube. Can you clearly see my vertices in the cube? This cube has vertices A, B, C, D, E, F and GH. Now if I compress this square on the front, if I compress this square on the front, which square is on the front? E, F, GH. If I compress it a little bit and push it towards the back, right? If I compress this, the first square of the cube, and if I push it towards the back, which square am I talking of? Which is having vertices E, F and GH. So the square with vertices E, F and GH will be compressed little bit and pushed backwards. So I will get exactly the same graph. So what am I going to get now? I will get a graph like this. A, B, C, D, and the square on the front with vertices E, F and GH will be compressed a little bit and pushed back E, G, H. So now, see. So didn't I get the same graph as graph G? So as I told you, a little bit of imaginative skills and a lot of practice can help you achieve this. So this is just similar to my graph G. So now it is quite easier for me to find the mapping between graphs G and graph H. Now I will erase the original graph H and see. Now it is easier for you to find out the mapping between these two graphs. So write the first vertex. The first vertex can be mapped onto vertex A. Then the second vertex can be mapped onto vertex B. The third vertex can be mapped onto vertex C. The fourth vertex can be mapped onto vertex D. Now, the fifth vertex can be mapped onto vertex E. The sixth vertex can be mapped onto vertex F. The seventh vertex can be mapped onto vertex G. And the eighth vertex can be mapped onto vertex H. Alright, now mapping has also been done. Now the next step and the last step is to validate this mapping. So, if there is an edge between 1 and 2, I can clearly see. So there must also be an edge between A and B. Yes, there is an edge between A and B, right? Then if there is an edge between 1 and 3, this edge I have covered. Now 1 and 3 there is an edge, so there must be an edge between A and C also. So yes, there is an edge between A and C. Now for this edge, there is an edge between 3 and 4. So that means there must be an edge between C and D. Yes, there is an edge between C and D. Okay, now for this edge, there is an edge between 2 and 4, right? So that means there must be an edge between B and D also. So yes, there is an edge between B and D. Okay, now the innermost square, there is an edge between 5 and 6. Yes, so that means there must be an edge between E and F also. Yes, there is an edge between E and F also. Okay, now there is an edge between 6 and 8. So there must be an edge between F and H also. So yes, there is an edge between F and H. Okay, so now there is an edge between 7 and 8. So that means there must be an edge between G and H also. Yes, there is an edge between G and H also. Okay, so the last edge, there is an edge between 5 and 7. So that means there must be an edge between E and G, between 5 and 7. So there must be an edge between E and G. So yes, there is an edge between E and G. So my mapping has also been validated now, and I can say that these two graphs are isomorphic. So by using these steps in this simple technique, you can easily find out for any two graphs if they are isomorphic or not.